Hello friends, welcome to the channel IT Simplified. Hope you're finding these sessions useful and subscribing to channel. In today's video in Azure, I'm here to talk about Azure Kubernetes Services, also known as AKS. So today we'll discuss what problem Kubernetes solves and what is the architecture when it comes to deployment on Azure. And finally, in the end, we'll see how it is to provision these services from Azure. But before we get into Kubernetes discussion, it will be a good idea to have a better understanding of what containers are and how it helps in terms of deployment of application. Now, I've taken a session when I did the Docker session about containers and its technology, but I'll just do a refresher to give you a better understanding of containers with respect to Kubernetes. So let's get started. Now, when it comes to application deployment, I can deploy this, say, for example, on a server. It can be a physical or a virtual machine. So, say this machine is running an operating system. It can be a Linux or Windows. And this machine has two CPUs and 10 GB of RAM, right? I can come and deploy an application here and it will work no problem, right? And in case I need more compute, I can go and definitely deploy another node and run that application. This can be load balance, and that was the way generally the application deployment used to take place. Then we introduce something what you call hardware virtualization, right? You might be already using this. So this is provided by a lot of companies such as VMware. Microsoft also has Hyper-V, right? Then we have from Citrix and Nutanix. These are some of the companies which provide this technology. Now, the advantage of using hardware virtualization is that this allows us to deploy multiple guest operating system. And yes, I'm talking about virtual machines. So these are all virtual machines I'm talking about here, right? And each of these virtual machine, as you know, will have their own operating system. Right here will have operating system of its own. This also has an operating system of its own, but that will allow us to, on the same node, I can have multiple virtual machine, and on these virtual machine, I can deploy my application. This significantly reduced the size of the data center because previously I have to deploy multiple nodes. Now on one node, I can have a multiple guest operating system, and on each machine, I can have application deployed. And this has worked for us, and we have been using this technology pretty successfully. Now, there's also another way of deploying your application, and let's take an example of a server. Now, again, this can be on a physical node or on a virtual machine, and this is what we call it operating system virtualization, right? In this, we can deploy an engine. Let's say I'll take example of Docker engine. So there is an engine which is deployed here on this machine. And what this engine allows us to do is I can deploy containers. I can have multiple containers here, very similar to virtual machine, right? Now, the difference between hardware and operating system virtualization is that, as you can see, that on VM, I need to have a guest operating system. When it comes to operating system virtualization, you only need to install the binaries which you require to run the application on these containers, right? So this is the application I'm talking about. Rest all the dependencies that it needs to run that application will be taken from the operating system. So this node will have, say, a Linux or a Windows, right? So say, let's take example of Linux because that's the most popular. And if your application requires anything from that, it's going to share those resources from the operating system perspective into this container to run this application. And you might have heard the term that containers are lightweight, and that is the reason they are lightweight, because you don't need to have a full-blown operating system here. I'm going to put containers here. And we have taken example of Docker, but there are different companies which provide this kind of capability. There is Rocket, even if I'm using container D. Basically, they do the same job. They give you the capability of operating system virtualization. But I hope that is clear how it is different from hardware virtualization, and how you're utilizing resources much more effectively as compared to your hardware virtualization, right? But still, I don't understand where does Kubernetes comes into play in all this in all this mix, right? Now, in order to further explain this, let me give you another example, and let's talk about monolithic versus microservices, right? Let's talk about this, and I'm sure you might have heard about it, but if you have not a problem. I'm going to explain this, right? Now, when it comes to monolithic, let's take example. I'm deploying a node here, right? And let's take example of Amazon application, because I think everybody has used this to do some sort of purchasing. And as a developer, if I'm coming here, I can write a code, right? I can run this code, and there is maybe a say a database which is attached to this. And Amazon is a very big application, so there will be a code which require login information. You have information about the cart, right, where you're putting your products. Then you have the product information, that the products that you're trying to purchase. Then you have the payment, right? What kind of payment you want to use? Do you want to use the gift card? You want to use the debit, credit, whatever the options. So you run this code in one go, and you deploy it on the machine, and you run it. Now, there is no problem with this, right? You can definitely do that. And if your application requires another node, I can come and deploy, I can come and deploy another node, and I can load balance, and that's fine, right? What happens in case I just want to change the product? So, say for example, Deepavali. Now, that's a big festival in India, and most of the people they're buying products for the near and dear ones, and there's a lot of traffic on Amazon during that time, right? So when Diwali comes, all the companies they're going to put a lot of discounts, a lot of promotions, so they will add a lot of products over here, right? What happens in case you just need to make changes to the product in monolithic kind of deployment or architecture? If you're trying to change maybe products, it might impact some of the other components in the application, and that might bring your application totally down, right? That's one thing. Other thing is that maybe your card, or let's say your payment, for example, doesn't need that kind of compute power what your products need, right? But the thing is, in monolithic, very similar to VM, that you have already pre-allocated your resources. So it's very difficult to optimize or segregate these components from one another. And that is where the microservices comes into play. So let's take the same example. And let's say I'm deploying the same application in microservices. What that means in simple term is I'm dividing all these codes into different nodes. You can call it nodes or in different containers, right? It can be across multiple nodes, right? So all these are containers. So what I have done is that I have segmented all the codes into different containers. So there is a code for the login on one, there's a card products. Now what this allows me to do is that I can attach, or maybe if I want to make changes to the product, I can just come and make changes to the products here, and it won't have any impact on the other components, right? If I want to make changes to the say payment, I can do that uh, in the code, and it won't have any effect. And if I have to add more containers over here, I can come add more containers on the same node maybe. Or if I add multiple nodes, if I add more nodes, so if I can go and spin up another node here, I can add more containers. So I hope you understand what and how effective is container in those sense. So that's why a lot of the companies, big companies like Amazon, Netflix, they uses this kind of technology. So that's great, right? So this is what container technology is, and obviously difference between monolithic and microservices. But still, we have not touched upon where Kubernetes comes into play. So now let's talk about that, right? So now let's say if you have a small application where you need maybe one, two, three, or four containers, that's fine. But what happens in case we are talking about hundreds and thousands of containers that needs to be auto scaled based on traffic, peak time, downtime? They need to be taken away once the traffic goes. It needs to be load balanced. What you're going to do, right? And that is where Kubernetes comes into play. Kubernetes is a container management tool, and it provides all the capabilities that I talk about. So if I have to auto scale, I can use this. I have to do load balancing. I can spin these containers down. I can add it, remove it. I can do versioning, right? All these things are capable now with Kubernetes. And the reason I'm talking about Kubernetes specifically because this has the biggest market share. Now, for example, as I said, that Docker is one of the company which is a pioneer when it comes to operating system virtualization, but it's not the only company. We have Rocket Containerd. Very similar to that, Kubernetes is just not the only company which helps us to achieve this. There is also Docker native solution like Docker Swarm, which allows us to do that. But I'm not here to talk about what is the benefits of this. The reason we are talking about AKS is that AKS is very popular, and AKS is available basically, or Kubernetes services are available in every public cloud. Not only in public cloud, you can deploy this in your on-prem environment too. If you have that and have that capability, you can definitely deploy that too. But since we are talking about cloud, I'm going to touch upon now the architecture when it comes to deploying AKS in Azure. So when we talk about any public cloud services, as you know that it's a shared model. And when I say shared model, what does that mean is there is certain services which is your responsibility, and there are services that will be taken care by Microsoft for you in this case. So let's talk about this one by one. So first of all, we're going to talk about the one which is Azure managed. It's managed. And then we also have customer managed, which is taken care by your customer, and it's your responsibility. When we talk about Azure managed, it can be divided into four categories. You have the API server, you have the database, scheduler, you have a controller, manager. Now, if I talk about this one by one, if I take example of API server, now this is how Kubernetes API are exposed. Now, this is responsible for provisioning, providing interaction for management tools such as kubectl or Kubernetes dashboard. That is the responsibility of API server. Then you have etcd. So this is basically responsible for maintaining the state of Kubernetes cluster and its configuration. So very important component within any Kubernetes deployment. You have scheduler. Now, when your application is created or scaled, scheduler is the one which determine what node can run on workload and basically start them. And then finally, you have controller manager, which is responsible for replicating pods and handling the node operation. But the good thing is that when we talk about AKS, this is all taken care by Azure managed. This is the control plane. It is also called sometimes the master node because this is responsible for managing the worker nodes. So this is the customer managed can be termed as worker nodes, right? I'm just going to put node here, right? This is an example of one node. Now, when we talk about customer managed, so there are different components to this, and let me just put this. Like for example, you have the kubelet, you have a kube proxy, container runtime, and you have container. All these resides on these nodes. For example, kubelet is the Kubernetes agent, which is responsible for orchestrating requests from your control panel, basically scheduling the containers, right? All those kind of stuff is done by kubelet. Now you have the kube proxy, which basically handles the VNet on or the virtual network on each node. You have the container runtime, which allows your containerized application to run and interact with your virtual network and your storage. But the important thing is that this is your responsibility. So think of a node as a VM, right? Since we are talking about cloud, that is how most of the time you're going to interact with. So you're going to deploy a VM of its specific series, right? Like a B series or D series, whatever series are there. It has a specific number of, say, CPUs or RAM. This is what you're paying from the customer perspective. So depending on what kind of node and how many nodes you're taking to deploy that cluster, you'll be paying for that. And just to point out about the cluster is nothing but, so say if I name this as cluster, a cluster is collection of multiple nodes, right? I can have one, two, three, this is nothing but a cluster, a Kubernetes cluster. But this is how the architecture of AKS looks like, right? You have Azure managed, so managed by Azure control plane, and then you have the customer managed, basically the nodes that you're going to deploy within that cluster. So this was a bit of background on the containers, monolithic versus microservice architecture. Uh, what problem Kubernetes solved. It's a container management tool, and the architecture on the Azure side. So what we're going to do is, to get a better hand of this, we are going to deploy a basic application. It's going to be a voting application on Azure, and we'll see what are the steps involved when it comes to provisioning this. So with this, I'm going to just flip over to my Azure portal. I'm already logged in. And to search for this, you can just type in Kubernetes. It will take you to this page. If I click on the add button, I have two options. I can add a Kubernetes cluster, or I can register a Kubernetes cluster with Azure Arc. Now, as I said, that if you want to deploy, you can deploy Kubernetes on-prem, right? Even if you have a Kubernetes in, say, in some third-party cloud, you can manage this and you can register this with Kubernetes cluster with Azure Arc. Azure Arc is one of the other services which allows you to manage your on-prem environment, or even your some of the third-party clouds that it can interact with. But for this demonstration, we are going to add a Kubernetes cluster on Azure. So let me go and pick that first option. And this should seems familiar to you, right? Most of these applications or any services that we're deploying, we have to fill up certain parameters here. So let's create a resource group. I'm going to name it, say, AKS RG. Resource groups is just a logical container. Then we need to give the name for the cluster. I'm going to name it ITS AKS, right? And pick your region that you want to deploy. I'm going to use Central Canada. And you have this option of deploying with or without availability zone. It's always a good idea because it will make sure that even if your entire data center goes down, you are still protected with availability zone. You can pick your version. I'm going to pick the default, and this is what the node size that you need to select, right? And this is what you're going to pay for depending upon what compute you want to use, right? So depending upon what region you're deploying, so all these are unlocked for you. Now for this demonstration, I'm just going to pick the default. And Kubernetes recommends that you have at least 3 nodes within the cluster for high availability, but I'm just going to pick one for the demo purposes. Then you have some more tabs, right? Your node pools, if you want to add more, how you want to authenticate, networking, integration. I'm not going to get into detail, but I just want to show you how easy or quickly I can deploy this voting application for the demonstration purposes. So let's go review and create, and click on the create button. So the deployment is initialized. So this is going to take a couple of minutes. So I'm just going to pause the video. Right, welcome back. So as you can see that our cluster was deployed successfully. So what we're going to do now is connect to cluster. And I can either use Cloud Shell, or if you have already downloaded Azure CLI on your local machine, you can use that too. But for this demonstration, I'm going to use Cloud Shell, which I'm going to open from here. And because Cloud Shell needs a file share, I need to create one. So let me pick my region, and I'm going to use my existing. So I'm going to deploy this everything in one resource group. You need to create a storage account and give the name for file share, and let's click on create. All right, so I'm inside the shell, as you can see. So the first command that I want to do is to set my subscription. So I'm just going to copy and paste this and hit enter. That's done. And now I'll get the credentials. And basically this is the resource group name, the one that we created, and the name of our cluster is ITS AKS, and let's hit enter here. So both of them ran successfully. Now what we're going to do is actually, let me clear the screen here. The command that I'm going to right now is to basically get my node, cluster node information, for which I'm going to type is kubectl get nodes. This get the list of the cluster nodes that I have, and I have to make sure that it is in ready status. Just waiting for this command to run. And you can see that this is the agent pool that I have. The status is ready, and it was created 5 minutes and 11 seconds ago, and the version is 19.11. Now what we're going to do is, now we're going to create a file with the name Azure Vote. So it's going to be a YAML file, and for that I'm going to write the command. And let me hit enter. It will open the editor. And what I'm going to do is I'm just going to copy this code. I'm going to share this. This is also available on Azure documentation. So let me just copy this and put the code here. And as I said, that this is just a basic voting application. And after I paste this, I'm going to save this. Right. So let me just enlarge this if I can. All right, so what I'm going to do now to deploy this application, I'm going to use kubectl apply command. So kubectl apply, and the name of my file is azure-vote.yaml. Oops. azure-vote.yaml, and let's hit enter. Now can you see that this was created successfully and the deployment was also successful. There was no error. Now, if you want to just monitor the progress of the application, just to confirm, you can type in the command kubectl get service, and the name of my file is Azure Vote. It will also give me the front and the backend IP. let me hit enter. So you can see that this is the external facing IP and this is a cluster IP. And I can use this IP and hopefully I will be able to hit the application and it's listening on port 80. Now, if you want to come out of this command, you can just type or you can just press Control C on your keyboard and you'll be out of this command. So let me just copy this IP and let me try to browse to it. And as I said that this is just a basic voting app, so you can vote uh, over here, right? I can just reset this and you can add, right? So with this we have successfully deployed an application through Azure Kubernetes services. So this gives you an idea about how to deploy this, but the most important thing I wanted to touch upon is what Azure Kubernetes services is and what problem it is solving. So container is good, but you need to have some sort of management tool which AKS provides you. And you can use this not only for deploying this on an Azure, even if you have on-prem deployment or even in third party, you can use the services to manage that through Azure Arc. So this was a quick overview or introduction on Azure Kubernetes services. Hope you found this useful. Thanks for watching. Have a good day.